Hi everybody, Nick Smith here. I've got a real short video that I wanted to just run through. We've had a few questions of late through the support help desk at Lighting Reality about energy calculations and how we do those. And also I had an inquiry today from somebody who wanted to know where we get the information from. So I've opened up the roadway program. And I'm going to tick the energy calculation option. What I'm actually going to do is I'm going to change it through to illuminance rather than luminance, because we're going to be probably dealing with some lower wattage fittings. So we can go to choose luminaire. We obviously go through the building database process, and that's reading the directory structure. And we can then go through and look up the photometric file that we want to use, or the product range that we want to use, because it may be that you're not sure which product you actually want to use. So I'm going to use a DW Windsor product. I'm going to use the Kirian Pro, and I'm going to look at the 3K 3000 lumen option that they have. Oh, not that one. Let's go with the mini. It might be more likely to produce a result. So we select the product range, and because I've got the energy dialog box open, which is up here at the top, you can see that it's reporting that it's a 4-watt fitting, and we've got no additional power that we've added in, and we've got no parasitic power that we're adding in. So the total wattage of that is 4 watts. So that's fairly straightforward. What we do when we select the EN13201 grids, it does an additional calculation associated with this energy tick box, and that is the power density, which is watts per lux per square meter. And it also does the annual energy consumption indicator, which is kilowatt hours per meter squared. Now, for the AECI, you need to set up the watts, the hours, the burning hours per year for the area where the fittings are going to be. And obviously, I'm based in the UK in the Midlands. It's about 4078 is the energy, which is why it's set to 4100. It's about the right figure, but you would obviously need to get the figure based on the switching regime and the location you are in the country, and that will give you the right calculation. The watts per lux per square meter is obviously based on the energy consumption of the fitting. It is based on the light level that's achieved on the carriageway, and we obviously know the dimensions of the grid, the width and the length, so we can work out whatever the area happens to be, and from there. So when we go into the optimization box here, you can see initially it was producing no results. Actually, let's not do a P1. Let's try and do something a bit more realistic. Let's go with a P5. So we're looking for an average of 3 and a minimum of 0.6, and as it's going through that, it's calculating an optimum and a minimum spacing, and it's also calculating the power density and the annual energy consumption indicator. 256 options, so a little bit of time for it to calculate that. We're getting to some results that I'm starting to like the look of. I'm getting up into the 40s now. 46 is a bit too high, perhaps. 48. I'll just leave it running for another couple of calculations. Right, we're starting to get X's now, so we're getting fails. So I'll stop it at that point. So I can now go down through the photometry list and look at different options. So I'm looking for somewhere about 39-40 meters. If I stick with 40, I've got a 28 watt fitting, a 22 watt fitting, is that right? A 29 watt fitting, and so on. So okay, power cut there, nice one. So in true terms, if we wanted to go with the lowest one, we would go with the lowest wattage, but in practical terms, we were looking for the best solution. So 39 to 27, 40 to 27. It's a slightly higher wattage at 27 watts, but that may be that gives us the solution or the spacing window that we're looking for. Obviously, the further apart the poles are between the maximum and minimum spacing, the more flexibility you have in setting the columns out on the design and making sure they're not in front of windows and all those types of things. Okay, so in terms of energy and wattages, let's just have a quick look at that. So the value that appears up here, we read straight out of the photometric file, and you can see here this is an IES format, LM63 2002 format file. And you can see there the field where the wattage is, which is 27, and when we look through others, you can see how the values are changing. Up here, this field here, so that's a 19 watt fitting, 24 watt, and so on. So if you know where to look in the photometric file, it's not a difficult value to find. It's on the final line between the angles in the C and the gamma plane. So it's the last one in that particular row there. If you need to know more details, then take a look at LM63. Obviously, you can purchase that from the usual supply points. So the alternative to that is ULMDAT, and our friends at ASD, they use ULMDAT format. So we need to go look through that. Now, whereas IES is based on a specific position in the file, a specific reference, ULMDAT is based on a per line basis. So this particular line here is the one where the wattage is. It is sometimes difficult to find it if you don't know where to look. So I find a good way of doing it is you look up the wattage, find out what it is, and then see where we can go in terms of finding the right value. So, and then I like to arrange this dialog box so that it's right down the very bottom of it, and so as I flip down, I can look at the different wattages and see where those happen to be as well. So again, as before, we can optimize the folder. And as we go down, we get the maximum and the minimum spacings, and we also get the power density and annual energy consumption indicator. I'm going to stop it there, and we can then go through and look up the various different options. So I can look up the power density to see if that's an option, or I can use the wattage to determine. Now I've got a 19.3 watt fitting there, so I can then from there look up the most suitable solution for this particular project. Most likely that one there I would go for in this case. Again, I'm looking at the flexibility it gives me, but at the same time giving a good value for the power density. Now if we sort it by power density, what we can do then is we can then go through and look at, and in theory the one with the lowest power density value is the best solution in terms of energy consumption. But as you can see here, it doesn't give me much flexibility in terms of spacing. It only gives me a 2 meter spacing window there. That one there gives me 4, and we can then go through and find something that is more suitable. That's the 21 watt fitting that I was looking at earlier, which does seem to be coming back to haunt me. So in terms of the different options that are available to us, those are the two principal file options that we use that have the wattage in it. I hope you have found that useful. If you have any questions, please message me in the area below. You can also drop me an email to support@nicksmithassociates.com or support@lightingreality.com, and that will get through to me as well. You can tweet me nicksmith1246 and ask me a question through that, or you can post a message in YouTube, which will come through to my YouTube, to my Gmail account, and you can message me in that way, and I can get back to you and hopefully answer your question. Thank you very much for watching. If you like the video, please don't forget to like it and subscribe to the channel so you will get future updates as and when they come out. So thanks for watching, and I'll catch you in the next video. See ya, bye.